At the top of page 16 is where they're going to introduce us to solving word problems. Word problems is where they want this lesson to go. It's not about can you take a square root, can you take a cube root. They want you to be able to solve these real world problems. Read the problem below, then explore how to use square roots and cube roots to solve word problems. City Park has a square piece of land with an area of 10,000 square yards. What is the length of the fence that encloses the park? Anytime you're looking at a word problem, look to see what's important. The first thing they tell you is that it is a square piece of land. Okay, that should give you a mental picture of what the shape is. It's a square. Squares are special. It has an area of 10,000 square yards. Now remember, area is two-dimensional. That's why it says the yards are square. What is the length of the fence that encloses the park? The question that they ask should always be the most important thing that you see. Now, I want you to understand something about this problem. They're telling you it's a square. They're giving you the area. Okay, they're telling you the product of two dimensions. They want to know the length of the fence that encloses the park. They do not want to know the length of one side. Okay, they want to know the length all the way around the park. They want to know the perimeter. This is where they're going to get you. They're going to give you area. They're going to ask for perimeter. They're going to give you volume. They're going to ask for area. Okay, they want you to be able to go from three-dimensional to one-dimensional to two-dimensional, or from one-dimensional to three-dimensional to whatever. Okay, that's where they're going to get you. If you do not read these questions very, very carefully, you will make mistakes. Okay, you'll have the right answer, but it will not be the answer that they're asking you for. So be super careful on these. Now, they are starting with a diagram. Diagrams are great for word problems. If you can draw a diagram, I recommend it. The park is a square, which is why they made their park square. The fence runs along the outside edge of the park. They also said it encloses the park, which is how we knew it went all the way around the outside edge. Now, the area of the park, this is two-dimensional, okay, the surface area, all of this space in here, is 10,000 square yards. Okay, we see that square. That square should indicate to you this is a two-dimensional measure. Now, if you want to go from area to a side, you would use the formula area equals side squared. That is your area formula for a square. It's very important. Now, the length of the fence is the perimeter. They're telling you they want to know all the way around the square, not just one side. If you solve area equals side squared, it's going to give you one side. It's not going to give you the perimeter. To find the perimeter of the square park, you need to know the lengths of one side of the square. So we do need to know the length of a side. We just need to remember we have to go one step farther. Now, they're saying to let F be the length of one side. So instead of area equals S squared, they want us to use area equals F squared. Please understand that the variable does not matter, okay? They're using F. We typically use S. It's interchangeable. Just take out the S, put in the F, and you're good to go. Now, area of the park is 10,000 yards square. Area is equal to F squared, so we could plug in that F squared is equal to 10,000. Or if you had area equals F squared, you would say area equals 10,000. I'll plug in 10,000 for the A. And this would be your new problem. Okay, either method is fine. I'm going to slide to the top of the next page. Now you will solve the problem from the previous page. What number squared is equal to 10,000? Now, everybody should instantly go to 10 in your mind. because you know all those zeros, we're just multiplying together some multiple of 10. Now you could factor it to find it. I'm going to show you both ways. Or you could just do the multiplication. You know that it's not 10 times 10 because 10 times 10 is 100. You could try 100 times 100. You could try 1,000 times 1,000. You can keep trying until you figure it out, or you can factor it. If I factor 10,000, the number I want to start with is not 2. I know I told you 2. 2 is way too small for 10,000. Start with 10 because it is so easy to divide by 10. 10 times 1,000 is 10,000. 10 times 100 is 1,000. And 10 times 10 is 100. Now this was a square root that we was trying to find. So we need pairs, okay, sets of 2. We've got 2 10s, which would factor out a 10. We have a second set of 10s, which would factor out another set of 10. Now, there is nothing left under the radical, so we can get rid of it. The square root of 10,000 is 10 times 10, which is 100. Number 9, they're going to show you solving it in equation form. You're still going to end up factoring it. Okay, F squared, or the side of the park, squared is equal to 10,000 yards squared. We want to know one of those dimensions. So to get rid of the 2, to get rid of the square, we do the opposite, which is a square root. Anything we do to the left, we must also do to the right. So we'll take the square root of 10,000. Now, we've already said that the square root of, 100 squared is 10,000. So F, or a single side, is equal to 100. And this is yards. Single yards, not squared anymore. So number 10 says, what is the length of each side of the park? Well, the length is 100 yards. Write and solve an equation to find the perimeter of the park. Now remember, perimeter is the distance around. So perimeter would be adding together each of the sides, and I should have used an F, I'm sorry. Okay, we would add together each one of the 4 sides of the square. If each side is 100, it would be 100 plus 100 plus 100 plus 100. Or you could have done 4 times 100 and got the same answer. The perimeter is 400 yards. The park's rectangular garden area is 450 square yards. They're giving you a new question. They're starting you out by saying, this question has an area of 450 square yards. Its length is twice of its width. They did also say it was a rectangle, so that's why it's not sides. It's length and width. The length is twice its width. Find the dimensions of the garden. They want us to find the dimensions. And begin with the equation 2W times W equals 450. The reason the formula is 2W times W. Now, area for a rectangle is length times width. They told us that the length is twice the width. So L is equal to 2 times W. They didn't tell us anything about the width. Yes, Trevor?
Or like, you can also say depth, you know.
Mm-hmm. We could have.
Also say it like instead like.
Now, area is equal to 2 times W times W. And if we wrote that with exponents like we're supposed to here, the area is equal to 2, and then W times W makes W squared. They wanted you to see that with an exponent. Now, they've already told us that the area is 450, so I'm going to take out that A. I'm sorry, I got ahead of myself. So 450 is equal to 2 times W squared. Now they want us to divide both sides by 2. They want us to divide by 2 to get the W squared alone. Don't take the square root of 2W squared. Okay, the 2 has not been squared. Only the W is being squared. We need to get rid of the 2. We'll do that with division. 450 divided by 2 is 225. And 2W squared divided by 2 is W squared. That's all kind of crammed in there. Now we can take the square root of both sides. The square root of W squared will be W, and the square root of 225, if you memorized your table like you were supposed to, is 15. So the width of the garden is 15. We still need to know the length. The length is twice the width, which would make it 2 times 15, which is 30. Got some additional examples down here at the bottom. Number 14, the volume of each cube is 1,000 centimeters cubed. What is the length of an edge? Now on this one, we are just going from three-dimensional measurement, it's volume, it's cubed, to a one-dimensional measurement. So we want to go from cubed to a single side. So what we're going to do is we're going to set that equation up. The volume is 1,000, and that would be the side cubed because that's the formula for volume. To eliminate the cube, we'll take the cube root. Anything we do to one side, we have to do to both sides. The cube root and the cube will cancel, leaving just s. And if you factor 1,000, you get 10 times 10 times 10, telling you that the side measure is 10. So the length of an edge of that cube would be 10. Number 15, a gift box in the shape of a cube has a volume of 216 centimeters cubed. What is the area of the base of the box? They're giving us the volume. They want to know the area of the base. They want us to go from three-dimensional, okay, they're going to go from a cube. We have to go down to one-dimensional to find one side. And then they want us to go back to two-dimensional to find the area of the base of the box, okay? So we're going to start with volume. We can go from volume to one side by using the formula volume is equal to side cubed. The volume was 216. So take out V, plug in 216. To cancel the cube, we take the cube root of both sides, leaving us s on one side, and the cube root of 216 is 6. So this gift box has a side length of 6 centimeters. We want to know the area of the base, and to find area, we take side squared. We just said that the side is 6. And 6 squared gives us 36. And it would be 36 centimeters squared. I'll give you just a minute for that one. Scientists find the temperature of a sample at the beginning of an experiment is T degrees Celsius. After 1 hour, the temperature is T squared degrees Celsius. If the temperature after 1 hour is 81 degrees Celsius, what are the two possible original temperatures? What is the difference between those possible temperatures? Now, when he started the experiment, he was at T degrees Celsius. Okay, that's not T to the 0, it's T degrees Celsius. And that was at the beginning. After 1 hour, he was at 81 degrees Celsius, and they want to know, oh well, that was at T squared. T squared degrees Celsius at 1 hour.